we study about the next characteristic of dot product of two vectors. Fourth characteristic, theta is equal to 180 degree, p dot q is equal to minus pq because of cos 180 is equal to minus 1. And if the two vectors are perpendicular to each other, their dot product is 0. Now, we study about the sixth characteristic of dot product of two vectors. Characteristic of dot product of two vectors, sixth characteristic, if the vectors are in rectangular component form. If the two vectors, p vector and q vector, are in a rectangular component form, where p vector is equal to px I vector plus py j vector plus pz k vector. I, j, k are the unit rectangular vectors along x, y, z axis respectively. And similarly, q vector is in the form of rectangular component form qx I vector plus qy j vector plus qz k vector. Two vectors are in the form of rectangular component form px, py, pz, and qx, qy, qz are the components along x, y, z axis respectively of the two vectors p vector and q vector. Therefore, dot product of two vectors means p vector dot q vector. By using the characteristic of if two vectors are perpendicular to each other, means I vector and j vector, both vectors are perpendicular. I vector, j vector, I vector, j vector and component along z axis x, y, z, k vector. X axis and z axis are perpendicular to each other, therefore I dot k is 0. Their dot product is 0. Therefore, I dot j is equal to 0. I dot k and j dot k is equal to 0. Two vectors are perpendicular to each other, their dot product is 0. Therefore, I dot j 0, I dot k 0, j dot k 0. Then calculate px, p component px I vector plus py j vector plus pz k vector dot qx I vector plus qy z vector plus qz k vector. Product of both means px I vector dot qx I vector plus qy z vector plus qz k vector plus py j vector dot that bracket py j vector dot qx I vector plus qy z vector plus qz k vector and plus pz k vector dot qx I vector plus qy j vector plus qz k vector. Therefore, px qx in bracket I dot I dot product of self vector means the next characteristic I dot I. Unit vector, its direction is the product of its along itself. I vector dot I vector means unit vector its magnitude is 1, magnitude of unit vector is 1 and cos 0. Cos 0 is equal to 1 means 1 multiplied by 1 is equal to 1. I dot I 1. J dot J is 1. K dot K is 1. But I dot J 0. I dot K 0. J dot K 0. Self dot product is 1 of unit vector and the vectors are perpendicular to each other, that dot product is 0. Therefore, Px Qx I dot I plus Px Qy I dot J plus Px Qz in bracket I dot K plus Py Qx J dot I plus Py Qy J dot J plus Py Qz J dot K plus Pz Qx in bracket K dot I plus Pz Qy in bracket K dot J plus Pz Qz in bracket K dot K. I dot I 1. I dot J 0. I dot K 0. J dot I 0. J dot J 1. Only same dot product terms are remain, otherwise 0. Their dot product is perpendicular to each other. Their dot product is 0. Therefore, the remaining factor is I dot I 1. Therefore, the term is Px Qx plus Py Qy plus Pz Qz. Therefore, dot product of two vectors in the form of rectangular component form is P dot Q is equal to Px Qx plus Py Qy plus Pz Qz. I dot I 1, J dot J 1, K dot K 1, I dot J 0, J dot I 0. The vectors are perpendicular to each other, their dot product is 0, but same dot product of unit rectangular vectors I dot I, J dot J, K dot K is 1. These are the properties of scalar product of two vectors. And the last property, if the two vectors are the adjacent sides of parallelogram or are the adjacent side, the work done should be calculated. For example, work done, 7 characteristic, work is a scalar quantity. Work is a scalar quantity because of, by definition of scalar product of two vectors, the scalar product of two non-zero vector is a scalar. Therefore, work done is equal to force dot product of displacement, means Fs cos theta. F dot S is equal to Fs cos theta. Means work done should be calculated by using the dot product of force and displacement. Therefore, if the displacement is in the direction of force,